So jumping back into Rhino then, I'm going to close this real quick so I can get it on the video. But basically, Grasshopper is not its own software. It's a plugin for Rhino. So what that means is that if I have see, I don't use the menus. I'm a typer. Right, so if I have kind of a surface like this, and it's a sphere, right? So I made a sphere in Rhino. This sphere it's a solid. Well, he'll describe what solids really are because they're not really solid. But it's basically a surface, right? It's a spherical surface that the computer computes in a three-dimensional space on the coordinate system. Grasshopper will do the same thing, except you have to write it in like it's a command, and it opens up Grasshopper. So I created a geometry right now that lives in Rhino. Okay? Grasshopper, while it looks like it has a grid here, this grid is really nothing more than like a sketch pad. And I'll talk to you about, what it will be used for. It is used to create spheres and boxes and other geometries and stuff. But what it does is it takes all the information that you put on this little sketch pad and it pushes that geometry back out into Rhino. And I'll show you the difference real quick. And I'm not really going over the user interface right now. I just want you to understand the relationship before I go into it. But basically, if I go into surfaces and I create a sphere like this, what you see is that it actually put in, let me get perspective, it actually put in a little sphere at the origin point of the coordinate system. So they're different, right? The one that I put in here is a black sphere, and it's the size that I gave it, but I dropped in this little tiny, it's called a node, this little node, and it put in, not only did it put in this little red sphere that's kind of see-through, but it also put a little grid on it as well. So the point that I want to make to you before we get into any of the user interface is that Grasshopper uses nodes that are packed with information to do the same thing that you do with a manual operation in Rhino. So if I wanted to change the sphere in Rhino, I have to delete it or do a scale command and change the size. So I delete it and make a new one in a new location, or I have to move it or something like that. But if I want to change the size of a sphere in Grasshopper, I just need a slider and I plug it into the size and I can change it. Or if I wanted to change the location of the base point for it, then I can move it around in space as well. So that's the difference between what I would call, static digital modeling versus parametric digital modeling. Rhino is static because you build it and then you have to modify it like it's a sculpture. Grasshopper is parametric, so it's all built off of, in many cases, mathematical, but I'll just simplify it by saying relationships to each other, all the geometry that you're making. Okay, so on a very, very base conceptual level, do you understand the difference between the two? Do you have any questions about those two spheres? Yes?
Is it like Dynamo to Revit?
Yes. Yeah, very good. Yeah, so you're a Revit user then.
I took a class, Revit 2 looked like last semester. So
right. Yeah, so that's very good, and that's a very good thing to point out. The generic term for this kind of computer program or computer processing, command processing, is called visual programming, where basically what you're doing is you're writing a script that takes the algorithmic data, relationships of all the geometry here, And it makes it something that's kind of visually pleasing, like a little wiring diagram. You're just kind of stringing all the spaghetti together. It creates those relationships that you would otherwise have to type in using programming language, which means you have to know all the syntax, you got to know where all your spaces have to go, your semicolons, your quotes, and all that other stuff. Right? This gets rid of all that. Okay? And the most important thing that I want to point out about that is that Dynamo for Revit, Grasshopper for Rhino are not the only two programs that do it. It's been happening for the last 30 years. Excel is a visual programming software. Because you notice how you take all of your formulas and you tie all the different cells together, and that data gets processed behind the scenes. Right? So it's all over the place nowadays. So it's a very powerful thing. Any other questions? Yes?
I was just going to ask if using Grasshopper or creating different types of geometries requires a little bit more of a heavy-duty like graphics card or something. Because my computer, as it is, it runs Rhino fine, but once I start making large objects or working on a project, and I turn on like the ghost option or like the shaded view, it gets really, really slow.
You're on the right track, but you're not 100% correct. With something like this, it's about processing data more than it is about actually producing the graphic. So while a graphics card will help on the back end, the most important thing that you can have for that sort of thing is a really good GPU. Or not a GPU, sorry, CPU. CPU being the computer processing unit, and GPU is your graphics processing unit. Do you know the difference?
Well, yeah.
Okay, so
You just stated the difference.
yeah, so there's processor, and then there's your video card, which has a GPU on it. So the processor is going to be one of the most important things that you have. Because it's trying to compute millions of things at once sometimes, depending on if you made a mistake. So, and I guarantee you I will make some mistakes where it's trying to compute, 5 million points versus 500,000. And, you'll see what happens. But I'll try my best to make sure that I'm not doing that to you too much, but it's all part of the process with this sort of thing. But there are some cool ways that you can kind of turn processing off while you're getting a string together, and then you can turn it back on and it'll compute, so you don't get hung up every step of the way, every connection that is trying to compute.
Yeah.
That's a little more of an advanced subject than most of us would be on right now. So he's just looking ahead at all the mistakes I'm going to make later, right? So, yeah, any other questions? I think I saw it. Yes?
Before you start on the...
Oh, on the video? Yeah, thanks. I thought there was another question before I move on. Yeah.
So, basically just more of the nodes that you attach, the more complicated, like if you wanted to add like an indent into that sphere, it's just like indented, you can add a specific node that tells it to do that?
Well, actually, that's a very good question. It'll take me, I'm not going to do it right now, but it'll take me a little while to string it together. It's actually not as complex as you would think. Basically, it's exactly the same thing as you would do in Rhino, except you string it together in a logical sequence here, and it gives you a post product. So in Rhino, you would take a sphere, and let's say you want to take another spherical cut out of it, then you'd have to build another sphere, put it in the location you want, and then you would subtract it out, and you'd be left with that cut. In Grasshopper, you build the two spheres, you put them in the proper location, and you tell it to cut it out. The difference is that Grasshopper still has retains all the original geometry and data because it lives in the string. And we'll get into that, basically, and this is, kind of the final thought, I think, on this part of the video before I go into the user interface. You'll hear this from me time and time again, that Grasshopper is a process of continually constructing geometry and then deconstructing geometry into bits and pieces and then reconstructing it into something else. It's the best way that I have to describe it. So basically, if you think of like these windows up there, see how there are separate panels of windows? And each one has what's called a mullion in between and on top and on the bottom. In Grasshopper, if you were to construct that, that whole ribbon would be one surface. And that's your construction phase. The deconstruction phase is that you take that surface and you subdivide it into panels and further subdivide it into lines. And then you assign those lines to be mullions. Does that make sense?
Yeah.
So I'm speaking very conceptually, so don't worry about the commands and all that stuff yet. But I'm just saying, like in Rhino, the difference would be that you'd have to draw a profile and extrude, or you'd have to draw a deep surface and then cut out each one, and then model another surface inside. It's a very manual versus a very parametric process. You getting it?
Yeah.
So construct, deconstruct, reconstruct. Construct, deconstruct, reconstruct. It's a cyclical process. You keep going through it until you get to the point that you want at the end. Okay? So, you know, it's a logical difference, but don't worry, I'll walk you through it. We'll start off very simple. So I'm going to stop the video here and I'm going to move on to just showing you the user interface.